We're back. Video 3, 15 minutes to teach you about molarity. Or else I have to do a video 4, which I don't mind. Molarity. What is it? Moles of solute divided by liters of solution. Molarity, also called amount concentration, really simply shows you what kind of concentration you're dealing with. Is this a highly concentrated hydrochloric acid? Or is it a not so concentrated hydrochloric acid? Depends on the molarity. Depends on the amount of solute that was added to the solution. And, of course, the higher solute amount, the higher the molarity is in the solution. The math is actually really easy if you understand the formula. Let me write out the formula, and I suggest you do so in your notes. Molarity, A-R-I-T-Y, sorry, forgive my cursive, equals moles of solute divided by liters of solution. I-T-E-R-S, liters. Moles of solute divided by liters of solution. Your test, along with your homework today, will have example problems exactly like the one on the next page. That is, what's the molarity of a concentration of 0.4 moles of potassium chloride dissolved into 0.8 liters of water? So, we have what's the molarity. So this is what we're finding is molarity. What's the molarity? That's our variable. Of how many moles of potassium chloride? 0.4 moles. Okay, let's go back here. 0.4 moles of potassium chloride in how many liters of water? And that was 2.8. Double check. 2.8. And liters, and this is moles, if we include the units. And I have my nifty calculator here on my phone. And I'm going to look up 0.4 divided by 2.8. And we get, wow, what a small number for our molarity. The molarity is equal to 0.14, and I'm going to round up 3 molar solution. Not very concentrated, right? Not a lot of potassium chloride in the solution. That's the molarity of this solution. Now, alternatively, let's say I give you a certain solvent to dissolve something in, except I don't give you the amount of liters that is in that solvent. It's not in a measurable graduated cylinder or beaker or something like that. You only have access to its mass. That's when you use, instead of molarity, you use molality. One letter difference. Molarity, molality. Molality has an L, while molarity has an R. And there's no real good way to remember that besides that the molality uses kilograms, molarity uses liters. I wish that the L stood for liters, but it doesn't. Don't get confused, okay? Molality is moles of solute divided by kilograms of solution. So if I have the molality of a solution is 8 molality, and there are 2 moles of solute, what is a mass of solution? Well, molality equals moles of solute over kilograms of solution. Let me write that in abbreviated form. Molality equals moles divided by kilograms. And we'll take a look. We have the molality is 8. Let's write that down. 8 equals how many moles? 2 moles solute. And how many kilograms? That's our variable. So we don't know the amount of kilograms. I'm just going to put kg as a variable. And so we have 8 equals 2 divided by our variable. And so we have to actually simplify this by multiplying kg, or the mass of the solution, over to the other side, kg. And then we have 8 kg equals 2. And we divide by 8. And we have the amount of kilograms, or the mass, is 2 over 8, or we could simplify that to 1/4. So this solution has a quarter of a kilogram as its mass, or 1/4 of a kilogram. And so all this requires really is simple algebraic skills. Although I'm sure you haven't done algebra in a little while, considering you are in geometry. This is alternative method and is only used when we have kilograms instead of liters, and that's actually a really rare occurrence. Molality is an art that is dying because most people measure everything in liters. That makes sense. You wouldn't say I drank 50 grams of water. You'd say I drank, half a liter or whatever it is. Okay? Last slide for today. And we are through. There are some solids, for example, the human skin, which are semi-permeable, allows some stuff out, like oil. Your skin allows some oil to be secreted out. Teenagers in particular have a lot of oil that leaves their skin, but not other things, like water. Now, some water is allowed to get through in the form of sweat, which has really a mixture of some random salts with water. But for the most part, water does not enter our body from the outside. That's a good thing, right? Or else we'd go swimming and we'd start to gain water, and that would not be good. Other solids are impermeable, allowing no substances to travel through. Okay, as a basic example, of course, you could say that if you put a sheet of aluminum foil and divide it up, the water on one side of something and the water on another side of something, the aluminum foil would stop the water from flowing back and forth to each side. Why? It's a solid. Aluminum foil doesn't allow anything to go through. Some solids are semi-permeable and allow some water movement. This water movement is called osmosis. And it's very important to our bodies. Let's look at the picture to the left and see why. If you go to a movie theater and you sit down and they have some really overpriced popcorn and some really, really overpriced drinks. They want like $9 for popcorn and $10 for drinks. Crazy, right? But of course you buy popcorn because you can't go and watch a movie without some popcorn. And the popcorn's extremely salty. And the salt gets in your body. And the more salt you eat, the thirstier you get, right? That's because the salt clings to water. And the water actually leaves our cells and goes into the bloodstream to form around the salt, because salt loves water. Because our cells are semi-permeable through osmosis. And so what happens? Our cells are thirsty now. They lack water. And so, you're eating all this popcorn, and then, of course, they show you an ad right at the beginning of the movie, and it's for some fresh Coca-Cola. and you're like, wow, that's what I want. And so you go and you get some Coca-Cola, and now you spent $20 on food and $6 on a movie. They got you. They won. So that's how they end up working. And of course, as you drink water or soda, the cells get replenished as the bloodstream gets filled with water. The water moves back into the cells, and now you have osmosis happening once more as water moves through a semi-permeable membrane back into the cell. And this happens in chemistry, and this happens in biology. You have some homework for tonight. That is section review 14.4, numbers 1 through 6, application numbers 1 and 2. And I have my textbook with me. Imagine reading a textbook at 11 o'clock at night. That's my life right now. These 6 questions on the section review, concept review are all terms that we have talked about recently. And the application, application number 1 deals with really solubility within a solution, and application 2 and 3 deals with the application of molarity and molality to a particular solution. I would especially focus, and don't skimp on application 2 and 3, because that's going to tell me whether or not you understand molarity and molality. And I'm going to use that on Friday to understand really how much I need to review it again when I get back. So double check those formulas. Molarity equals moles of solute divided by liters of solution. Molality equals moles of solute divided by kilograms of solution. And I use those 2 formulas to figure out applications 2 and 3, because that will be a mathematics section on this test. You won't want to miss it. It'll be exciting. All right, short lecture today, just 12 and a half minutes. I hope you have a wonderful day. You now have about 15 minutes to do your section review questions. And the rest of the time, that 10 minutes or so, 15 minutes, to complete there's a ambulance outside. To complete the worksheet that I gave you over molecular mass and Lewis dot structure. Have a wonderful day. Happy Thursday.